Okay, we're doing our example now. The example is a cosecant function. We can see here, cosecant. We know that cosecant is related to sine. Here's our cosecant function with no transformations. So let's think about what we remember about our 5 key things. We know there's asymptotes here at x equals 0, x equals pi, x equals 2 pi. Now take a look at the scale though on our graph that we have down here. The scale is different down here than it is up here, okay? So each grid mark here, it takes 2 grid marks to make pi. Each grid mark is pi over 2. So if there was no transformations in this cosecant function, we would have asymptotes at 0 and every pi thereafter, okay? But what is happening here? What does this guy do? Well, it creates a horizontal shift of pi over 2 units to the right. So we'll write that in here. Pi over 2 units to the right. So therefore that first asymptote, instead of being at x equals 0, will be at x equals pi over 2. So we're going to put that asymptote on here. Okay, now there are no there's no b value here, okay, in their transformational form. Transformational form of a secant and cosecant function looks exactly like all of our other trig functions. So there's no b value, which means b is 1. So there's no change in the period. So we know period is 2 pi over b. b is 1. So therefore the period is 2 pi. All right, so it'll follow this same pattern here. So there's a separation of pi between each asymptote. So let's put the rest of our asymptotes on. Remember, pi on the scale on this graph is only 2 grid marks. And back this direction as well. Lots of... Oh, I made a mistake, didn't I? Oopsie daisy. Okay, let's get rid of these guys. Rats. Wasn't paying close enough attention. Okay, let's get those back on there. We need some grid marks. Grid marks in black back here. Grid marks. These are just the grid marks I'm putting back on because I made a mistake. All right. The next asymptote needs to be 1 pi away from here. And 1 pi is 2 grid marks, so that asymptote should be here. Sorry about that. The next one here. And then here. Here. And on the other edge. All right, so next, let's take a look. We know for the cosecant function, normally we would have this point, pi over 2, 1, and 3 pi over 2, negative 1. But look, we have a vertical stretch of 2. All right, so that vertical stretch of 2 means that this is going to stretch up away from the midline. The midline of this function is the same as the midline or the principal axis of y equals sine x. So the midline is y equals 0, which is the x-axis, okay? So it pulls up twice as far away from the principal axis, from the midline, as it was with no transformation. So instead of being at pi over 2 and 1, it'll be at pi over 2 and 2, but remember it moved to the right as well. So it's actually going to be at pi and 2. So that's that point. So this point right here moves to the right by pi over 2, and then it gets stretched up 2. So here's our point, pi and 2. All right, what other point? We know we had 3 pi over 2. That got moved to the right by pi over 2, so it'll become 2 pi. And it was y-coordinate of 1 being stretched by 2, so 1 times 2 is negative 2. So that point will become down here. All right, this is our local minimum, so this curve will go like this. This is our local maximum, so this curve will point down and go like this. And this pattern will keep on repeating. So we do this. Down over here. Up over here. Down again. Up again. Down again. All right, there is our graph. Did we fill in all our information here? The vertical stretch of 2, the period is 2 pi. There's no horizontal stretch because B is 1. No horizontal compression either. Horizontal shift, pi over 2 units to the right. Vertical shift, none, because there's no D value at the end here. And our midline, our principal axis, is y equals 0.